Hey Kipsters, this is Matthew. Today we're going to be working on Module 4, Lesson 24, an Introduction to Simultaneous Equations. Take 10 seconds to make sure your heading is at the top of your paper and that you're looking at Lesson 4. This word simultaneous may be new to some of you, but the word simultaneous means at the same time. Alright, so when I think of simultaneous, I instantly think of television shows and them being shown in different time zones. So we're going to be talking about equations that don't necessarily look the same, but they are going to they're going to meet up intersect and meet at the same place at some point. The notation that we'll be using throughout the lesson today, you're going to hear me use the word system. A system, let's go ahead and add on the second word to it, a system of equations. A system of equations is what we're going to be working with today, and it's a pair of equations that have specific solutions. Specific solutions. Alright, exercise number 1. Derek scored 30 points in a basketball game play, and not once did he go to the free throw line. That means that Derek scored 2-point shots and 3-point shots. List many combinations of 2 and 3 point shots that would total 30 points. Remember, we used to do some annotation of our problem. Go ahead and make sure your paper looks like mine. Circling any numbers that stick out to me, and I am boxing out all of the operational words, my math action words. I am underlining my prompt for my task. So my prompt has to list any combination of 3 points that total 30 points. I'll help you out with the figures. So if we're talking about 2 pointers, 3 pointers, we're given a table below, and it's like, well, let's say Derek only made 2 points. If Derek only made 2 pointers and he had to have a total of 30 points, the number of 2 points would have to be 15. And know that because 2 is 30. And the number of 3 pointers would have to be, that's my total of 30 points. There's another combination of only one type of shot that Derek has. If Derek only made 3 points, okay, then that would leave make 0 2-pointers. I know that I have a total of 30 points because 10 times 3 is 30. What other combination can you come up with? Yeah, you should have come up with 12 2-pointers and 2 3-pointers, 9 2-pointers and 6 3-pointers, and 6 2-pointers, 6 3-pointers, and 3 3-pointers, 8 3-pointers. Now let's move on to prompt number 2. Let's write an equation that describes the data. I want to write an equation that describes the data. From previous lessons, you know that when we're writing an equation, we are using variables, so we need to define our variables. So let's let x be the 2 points and y be the 3 points. How can I use the variable x and the variable y to write an equation that describes the data? So I am going to start by using some words to describe the situation. I know that the number of 2 pointers has to always be multiplied by the number 2. That's going to be added to the number of 3 pointers, which has to be multiplied by 3. That is equal to total points. Now let's replace with what we've been given, 2. And I'm going to replace the number of 2 pointers with x, because x is the number of 2 pointers. And y, I'm replacing with the number of 3 pointers, is equal to my total points of 30 points. Turn the page. Here it tells you that the number of 2-point shots that he made is 5 more than the number of 3-point shots. How many combinations can you come up with that fit this scenario? Don't worry about the total number of. So how could Derek show that the number of 2-pointers he made is 5 more than the number of 3-point shots? Well, let's start by just picking a number. How many 2-pointers do you want Derek to make? I want Derek to make 6 2-pointers. I need my 2-pointers to be 5 more than my number of 3. That means Derek has 6 minus 5, which is 1. Go ahead and for the value, answer the questions as they pop up. So you should have that he would make 2 3-pointers with 7 3-pointers, 3 3-pointers with 8 3-pointers, 4 3-pointers with 9 3-pointers, 5 3-pointers, 10 3-pointers, with 6 3-pointers, 11. We're now being tasked to write an equation that describes the data. Thinking about my words from the previous example, I know I multiplied a 2 by my number of 2-pointers. I added that to 3 being multiplied by my number of 3-pointers. And that was equal to my total. Ask yourself, does this setup help me describe this data? No, because my number of 2-pointers is not multiplied by the number 2 and then added to my number of 3-pointers. What do you specifically know? I know that my number of 2-pointers, I know that my number of 2-pointers is, remember, is our equal sign, 5 more than my number of 3-pointers. I can substitute with my variables x and y, and I'm going to have that x is equal to 5 plus y.
All right, let's take a look at number 3. Which pair of numbers from your table in exercise 2 will show Derek's actual score of 30 points? In other words, when I multiply my number in this column by 2, and I add that to me multiplying my number in this column by 3, which total number of points equals 30? Yeah, the pair 9 and 4. The order pair 9 and 4 is going to give us a total of 30 points. There are some situations where we need to work with 2 linear equations simultaneously. Hence the phrase simultaneous linear equations. Sometimes a pair of linear equations is referred to as a system of linear equations. The situation with Derek can be represented as a system of linear equations. Let's let x represent the number of 2-pointers and let y represent the number of 3-pointers. If this is true, then the equation 2x plus 3y equals 30 can be stacked on top of the equation x equals 5 plus y. The notation for simultaneous linear equations looks like this, and it lets us know that we're looking for one ordered pair, some x, and some y that makes both equations true. That point is called the solution to the system. Just like equations in one variable, some systems of equations have exactly one solution, no solution, or infinitely many solutions at all. But that's a topic for another lesson. Ultimately, our goal is to determine the exact location on the coordinate plane where the graphs of the 2 linear equations intersect, giving us the ordered pair x and y. That's the solution to the system of equations. This too is a topic for a later lesson. Let's examine this graph. Now when we're looking at the equation of both lines on a graph, so I'm showing now the line 2x plus 3y equals 30. So this is Derek's original equation of every shot equaling 30 points. And this is the second situation for Derek where all of his 2-pointers is 5 more than his 3-pointers. When we plot them based on the given information, we see that they actually do intersect here at this 1 point. X of 9, y of 4. How could we verify that 9 and 4 is a solution to both of the equations outside of the graph? We could use some substitution. So we could revisit Derek's original equation, 2x plus 3y equals 30. And we can substitute this x and this y into the equation. So I'm going to write the equation like I've been given. And I'm going to substitute for 9, 4. So when I rewrite, instead of an x, I'll be substituting a 9. And instead of a y, I'll be substituting a 4 equals 30. Remember, step 3 is to always compute. So I want to do this math. 9 times 2 is 18. I know 4 times 3 is 12. Equals 30. Order of operations tells me to handle this multiplication first before I handle the addition. Continuing down, now that I've done all multiplication and division, I can now add, and I know that 18 plus 12, 8 and 2 is 10, 0 carry the 1, 1 plus 1 is 2, 2 plus 1 is 3. So I get a total of 30 on my left side, drop down to 30 on my right. Because 30 equals 30, I know that this is a solution to the equation 2x plus 3y equals 30. If I can do that for an equation in standard form, I should be able to do that for an equation for the second equation as well. So I'm going to write the equation like I've been given, x equals 5 plus y, and I'm going to substitute for the order pair 9, 4. And instead of an x, I'm going to substitute 9, and instead of a y, I'm going to substitute 4. Do my math on the right, I get that 9 equals 9. So because my left side equals my right side, I can say that 9, 4 is the solution to the system of equations.